now try to solve linear equations with variables on both sides, because till now it was quite simpler when you have constants on one side. Now if you have variables on both sides, then how do you go about it? So let us take an example of this type of an equation which has variables on both sides. So let's consider this. 5x plus 3 is equal to x plus 10. So you have variable here, you have variable here. So how do we handle this? So again here also we will follow the same trick. We will try to collect all the variables on left hand side. We will try to send all the constants to the right hand side. So for that what we would do, 5x minus x. So this x would have come this side and this 3 would go this side. So this would become 10 minus 3. So 5x minus 1x would be 4x. 10 minus 3 would be 7. So therefore x will be equal to 7 by 4. So this would be a solution for this equation. So you see the approach remains the same. It is just that you need to remember those simple steps when you transpose constants and variables from one side to another. So here what we are going to do is we will arrange all terms with variables on one side and we keep all the constants on the other side. So that is the simple mantra that we will follow to solve linear equations. So let us look at some other examples. So let's say you have an equation 5t minus 3 is equal to 3t minus 5. So here also we will send the variable here, we will send the constant here. So we get 5t minus 3t is equal to minus 5 plus 3. Or we can say 2t is equal to minus 2. Or we can say t is equal to minus 2 divided by 2. Or this is equal to minus 1. Therefore t is equal to minus 1 is a solution for this equation. So keeping these points in mind, let us try to solve some more equations with variables on both sides. Question number 1. Solve 4z plus 3 is equal to 6 plus 2z. So in this case, we collect all the variables on one side and the constants on the other. So we get 2z is equal to 3, or we can say z is equal to 3 by 2. So this is a solution for this equation. Question number 2. Solve x is equal to 4 by 5 into x plus 10. So in this case, what are we going to do? So what we will do is, to make it simpler, because due to the presence of 4 by 5, this equation is like looking a little different. So what we will do is we will send this 5 on this side so that we do not have this complexity of having a denominator extra. So what happens, this becomes 5x is equal to 4x plus 10. So now we will follow the same approach. So let us first find out the variable and the constant terms separately. Like here we have done 4x and plus 40. So now let's bring the variables on one side and the constant on the other. So we get x is equal to 40. Question number 3. Solve 2x by 3 plus 1 is equal to 7x by 15 plus 3. Here again the same thing. Let's bring the terms with x on left hand side. So it is 2x by 3 minus 7x by 15 is equal to 3 minus 1. So here 3 and 15, the LCM would be 15. So this would be 10x minus 7x and this would be equal to 2. So this is 3x divided by 15 is equal to 2, or we can say 3x would be equal to 2 into 15, or 3x is equal to 30. Therefore we can say x is equal to 30 divided by 3. So 3 tens are 30, so x is equal to 10 would be a solution for this equation. Question number 4. Solve 2y plus 5 by 3 is equal to 26 by 3 minus y. So here again 2y plus y is equal to 26 by 3 minus 5 by 3. So this becomes 3y is equal to 21 by 3, or y is equal to, here 3 7s are 21, so this would be 7 and this 3 will come here, so it will become 7 by 3. So y equal to 7 by 3 would be a solution for this equation. Question number 5. 3m is equal to 5m minus 8 by 5. So here again we bring all the m's on left hand side. So this is what we get. Now 3m minus 5m would be minus 2m is equal to minus 8 by 5, or m would be equal to minus 8 by 5 into 1 by minus 2. So 2 4s are 8. This minus and minus will also get cancelled. Therefore, m is equal to 4 by 5 as a solution for this equation. Move ahead with the next type of equations that we will learn to solve. So these are equations which are reducible to linear form. So here the equations would still be linear equation, but they will not appear in the same conventional form of linear equation. So the way they will appear to us would look complex, but we will see how we can reduce them to the usual form of linear equation. So whenever you find an equation of this form, where you have a numerator divided by denominator is equal to a numerator divided by a denominator, where these numerators and denominators are algebraic expressions. Like they could be anything like 2x plus 3x plus 9x plus 1, y plus 2. So anything of this sort. So whenever you have an equation of this form, something like this, let's take an example. 2x plus 3 divided by x plus 9 is equal to 1 by 2. Or sometimes even on this side you might have these kind of expressions. So when you have an equation of this form, now when you look at this equation, it doesn't look that simple like the usual linear equation, right? So you feel that don't know what to do. So the only thing that you need to do in this case is your first step should be to cross multiply. Now what do we mean by cross multiply? Cross multiply means you multiply the denominator on the right hand side to the numerator of left hand side. Similarly, you multiply the denominator of left hand side with the numerator on right hand side. So that is called cross multiplication. So in this case, what will happen in that case? 2 into 2x plus 3 will be equal to 1 into x plus 9. So that is what you will get. So in this case 2 into 2x would be 4x plus 2 into 3 would be 6, and this side it would be x plus 9. Right? So basically, you know, what are we doing when we are cross multiplying? Now basically when we are cross multiplying, we are actually multiplying this denominator on both sides. It is the same thing. If you multiply x plus 9 on both sides. Now why are we doing this cross multiplication? To keep things simple, because every time when you have to multiply something on both sides, first you will think what I have to multiply, then you will multiply that, so it will take more time. In this case, you just know all you need to do is you need to cross multiply with the denominator on the other side. So this is what you get. Now you put all the variables on one side like this and all the constants on the other side. So you get 3x is equal to 3, or x is equal to 3 divided by 3, that is equal to 1. So x is equal to 1 would be a solution for this equation. So you see, even though the equation looked complex, but we could very easily solve it. Now, one important thing that needs to be noted here is this rule is applicable only for equations in this form, and this rule is strictly not applicable for different forms of equation. For example, if you have an equation of this form, x by 2 minus 1 by 5 is equal to x by 3 plus 1 by 4. Now, is this equation in this form? This equation is numerator by denominator minus numerator by denominator. But here we said it should be numerator by denominator equal to numerator by denominator. So in this case, this rule will not be applicable. So you should not start cross multiplying here. So this will not be applicable for this case. However, if you have an example like x minus 1 by 2 is equal to x plus 1 divided by 12. So here you see it is in the same form, numerator by denominator, numerator by denominator. So here this rule would be applicable. So you can directly cross multiply. Again, let's take one more example. 6x plus 1 divided by 3 plus 5 is equal to x minus 9 by 2. So in this case, on the right hand side, it is in the form of numerator by denominator. But on the left hand side, it is not in that form. Here you have numerator by denominator plus a number. So therefore, here also overall the rule will not be applicable. So with these examples, what I'm trying to tell you is where exactly can you actually apply this concept of cross multiplication to solve the equation. So now you might say that, okay, fine. So we will be able to apply this concept only where this particular form holds true. But what about all these complex forms? Because even these look more complex. So how are we going to solve them? So how are you going to solve these complex equations? Tip, that is tip number 2. So let's say whenever you have equations in the form of numerator by denominator plus numerator by denominator is equal to numerator by denominator. So when you have something of this form, in that case what we do, we multiply both sides by LCM of denominators to get an equation in linear form. So things will become clear only when we take an example. So first of all, let us take an example in this form. Let's say x by 2 minus 1 by 5 is equal to x by 3 plus 1 by 4. So let's say this is our equation. So this satisfies the form. Okay, fine. Now let us try to find out the LCM. Now what would be the LCM of the denominators? What are the denominators here? So here the denominators are 2, 5, 3, 4. So if you find out the LCM of 2, 5, 3, 4, what would be the LCM? The LCM would come out to be 60. Just try to find out LCM of 2, 5, 3, 4. So you would get something like this. So 2 into 2, 4 into 3, 12 into 5, 60. Therefore, the LCM would be 60. Now what you do? Multiply both sides by this LCM. So that means x by 2 into 60 minus 1 by 5 into 60 is equal to x by 3 into 60 plus 1 by 4 into 60. So we have multiplied everything, both the sides by 60. So this would be 2 into 30. So this would be 30x minus this would be 5 into 12, 60 minus 12. This would be 3 into 20. It would be 20x plus 4 into 15. So this would be 15. So now again we follow the same thing. Collect the variables on one side. So it would be 30x minus 20x is equal to 15 plus 12. Or we can say 10x is equal to 27. Or x is equal to 27 by 10. So x equal to 27 by 10 would be a solution for this equation. So here you see what the only thing that we need to do is first we need to find out the LCM. So once we have found the LCM, then the entire work becomes very, very easy. So these are the tips that you need to remember. So looking at the equation, first you need to decide what is the form of that equation, and then accordingly you have to take the first step. So now I am sure that you must be confident to solve such equations as well. So let's look at an example of one of these equations. So let's say you are given an equation like this: n by 2 minus 3n by 4 plus 5n by 6 is equal to 21. So this is of which form? Type 1 or type 2? So this is of the form type 2. So here we'll apply our tip 2. So in that case what we do, we have to find out the LCM of the denominators. So here the denominators are 2, 4, 6. So this is how we find out the LCM, and the LCM comes out to be 12. 2 2s are 4, 4 3s are 12. So now multiply both sides by 12. So our next step is multiply both sides by 12. So this would be n by 2 into 12 minus 3n by 4 into 12 plus 5n by 6 into 12 is equal to 21 into 12. So this is 2 6s are 12. So this is 6n minus this would be 4 3s are 12. So this is 9n plus 6 2s are 12. So this is 10n is equal to 21 into 12. So we keep it as it is as of now. So now this side we solve, it becomes 16n minus 9n is equal to 21 into 12 or this becomes 7n is equal to 21 into 12, or n is equal to 21 into 12 divided by 7. So 7 3s are 21. So this would be 12 into 3, that is 36. So x is equal to 36 would be a solution for this equation. So you see, solving them is pretty easy. You just need to understand which concept or which process you need to apply.